A fraction that contains a fraction, that is a complex fraction. And we're going to solve a complex fraction in this example, example 2. Step 1, convert both the numerator and denominator to fractions. So the first step I'm going to take is I'm going to take this 9 and I'm going to convert it to a fraction by placing that 9 over 1. Then I'm going to really exaggerate this fraction bar in the middle, and then I'm going to record the number that is already in improper fraction. Remember, you can change any integer to a fraction by placing it over 1, because 9 divided by 1 is equal to 9. We've completed step 1. Step 2 says change out the fraction bar for the other division symbol. So I need to take out this fraction bar and replace it with the division symbol. You place the numerator first. So the number that's on top here, that gets placed first over here. And then you place the denominator second. And then if you have it in the proper order, you can nod that it's in the proper order. I'm sorry for the cheesiness. Then I'm just going to copy it again so I can complete step 3, which says keep change reciprocal. So we've done step 2. Step 3, we keep the first fraction. Doesn't change. It remains a 9 over 1. You change the division to multiplication, and then you record the reciprocal of 27/17, which is 17/27. I'm going to reduce diagonally. So I see that the 9 and the 27 can both be divided by 9. So I think in my head, 27 divided by 9 is 3. I circle my new number, the 27 is gone. 9 divided by 9 is 1. And I circle that new number 1. And then I look at the numerators. Now you have to be careful. There's a 17 that remains and a 1. That 9 was crossed out. So 1 times 17 is 17. And then in the denominator section, we see a 1. The 27 was crossed out and there's a 3. So 1 times 3 is 3. And I'm going to pause it and do the work the other way as well. So I magically made this appear because I did the work. I paused it and did this work. But this is the same thing, 9 over 1 times 17 over 27, but this time, instead of reducing first and then multiplying, I multiplied first, 9 times 17 to get the 153, there's my work, and the 1 times 27 to get 27, and then next I have to reduce. So I wrote over here 2, 3, 5, 7, and 10, those are the numbers I need to check. They're not divisible by 2, they would have to have an even number in the ones place. If it's divisible by 3, well, 27 I already know can be divided by 3. You can see my work over here. I added 1 plus 5 plus 3 gives me 9. And since 9 is a multiple of 3, I know I can divide 153 by 3. So I need to come over here and take the time to divide 153 by 3. 3 goes into 15 5 times. 3 times 5 is 15. I can't ask the question again until I bring down the 0, or bring down the 3, bring down a number. 3 goes into 3 one time. And I get 51 when I divide 153 by 3. So I get 51 over 27 divided by 3 is 9. Well, look at this again. 5 plus 1 is 6, and 6 is a multiple of 3, which means 51 is also able to be divided by 3, and 9 is able to be divided by 3. So 9 divided by 3 is 3, and I just don't want to take the time in the video to take 51 and divide it by 3, but, you know, that's how this process rolls, is you got to do all this work. So 3 goes into 5 one time. Subtract, we get a 2, bring down the 1. 3 goes into 21 7 times. 3 times 7 is 21. I think you see why, as a math teacher, I don't multiply across and then reduce. I reduce and then I multiply across. But once again, the way you want to do it, that is up to you. I'm just going to show you both methods and you make your decision about what works for you. Because you get the same answer either way.